cold fusion. This is a very controversial subject, and in 1989 we were looking for, working with some of these early Edisons, and we actually offered everybody who wanted to prove that cold fusion existed a copy of LabVIEW, and everybody who wanted to prove it didn't exist a copy of LabVIEW. And as far as I know, only the ones trying to prove it actually took us up on the offer. So we actually did an app note, how to do cold fusion with LabVIEW. So we've been there all along in this very controversial area. Most recently, a lot has happened since then. A guy Grimshaw did his master's thesis at the LBJ School of Public Policy, viewed as fairly neutral, saying he had found 184 examples of positive experiments in this area. And he recommended that public policy support research in this area. We also have been working with LabVIEW over the years on many of these Edisons in their basements, in their closets, in their out back laboratories in the back of their yard to continue this research. And we actually have a demonstration of Dr. Shalani's work from the Italian Nuclear Institute on the showroom floor.
Tell people that I have felt the radiating heat. I can feel it. Feel it with my hand. It's there.
Welcome, Dr. Duncan.
I appreciate it. Thank you.
Yeah. Can you share with us your perspective on some of these unsolved mysteries in the physics region?
Oh, certainly. Let's go back for a minute, about 23 and a half years, to the University of Utah, when Fleischmann and Pons announced and surprised the world with their announcement that they'd created fusion inside a room temperature apparatus without creating the harmful ionizing radiation that's also often associated with nuclear fusion. Well, this surprised the entire world and created a huge excitement for a very short time, but it plummeted as quickly as it rose. But to understand that event, you actually have to go back much, much further to 1926 in Berlin, when two physicists announced, well before we understood what a deuteron was, or heavy hydrogen, well before we knew about nuclear fusion, they announced when they put hydrogen and palladium, it would join together to create helium gas, was their claim. And this created a huge stir, got everybody very excited, a lot of exchange, and in the whole controversy, they later retracted that paper. Well, let's fast forward now to the mid-1950s. We had known about hot fusion, or fusion the way the sun works, what we call thermonuclear fusion. That was well established. But the big surprise in the mid-50s was that people discovered a subatomic particle called a muon could catalyze this fusion reaction between hydrogen isotopes at low temperatures. And this created, again, a lot of scientific excitement. And so, as that had occurred before Pons and Fleischmann, when they made their announcement, many people, including myself, were wondering, is there some physics that we don't understand in metals or solid state that could be somehow catalyzing this nuclear reaction? That's what we were all thinking. Well, as you might remember, there was a big, intense effort of many scientists around the world to try to repeat the Pons and Fleischmann experiment shortly after they announced it in March 1989. Well, those attempts failed, and people thought, well, this is just some massive mistake and it will just fade away from view. Well, as Scott Pelley said on 60 Minutes, a strange thing happened on the way to oblivion. What happened was, since that time now, 3 national labs from around the world and literally hundreds of other reports of scientists and professors have verified that this excess heat reported by Fleischmann and Pons is in fact real, is in fact correct.
rock.